We will hear from Dave Melendrez on Orion imagery. And of course, Orion is the crew capsule that will carry astronauts to and from the moon. And we'll be hearing about some Artemis 1 experience as well as thoughts on what's new for Artemis 2 and moving forward. Go ahead, Dave.
Thanks, everybody. Good afternoon. Why don't we go to the next slide, please? My role within the Orion program is I'm the Orion imagery lead, which means as much as I'm also a former planetary science guy, and I really love all this planetary geology and remote sensing chat, I also have to be the one to throw the unfortunate mud on the situation sometimes and say what the spacecraft is actually capable of doing. So this chart's a little bit busy. I'm not going to go into great detail, but this basically just shows you an overview of what the Orion imagery system looks like for Artemis 2. I know it's kind of busy. We've got a bunch of cameras mounted all over the spacecraft. There's one that you saw, I'm sure, from all the pictures we downlinked on Artemis 1. Each of the solar array wings has a little GoPro attached to the tip. Those cameras are pointed inward towards the vehicle. They're designed for vehicle inspections. But because the arrays can gimbal, we can point them outwards and look at various targets like the Earth and the Moon and things like that. But the lenses are pretty short. I don't recall the exact focal length. I want to say it's something like 5mm focal length lenses. So we can see the Earth and the Moon just like we saw in Artemis 1, but they're pretty tiny in the field of view. The main thing I think folks are going to be interested in, of course, are the DSLRs. We're flying 2 Nikon D5s. They're the exact same type of camera that we fly on station. We will have 2 different lenses, so the cameras will be pre-mounted. One will have a short lens for use inside the cabin, and the other one will have the long lens, which is an 80-400 that we can use for out the window ops. I think for planetary geology, I'm not going to focus too much on all the other cameras. Folks can ask questions if you like, but the Nikon is going to be the main thing that we'll be using for taking pictures of the moon. We will still look into the possibility of using vehicle cameras, of course, as able to get some pretty pictures of the moon. It all depends on, as Mark was talking earlier, what the vehicle attitude is going to be, what the lighting constraints are, whether we can, in fact, flip the vehicle over, whether we can maneuver a solar array. All these things have to be taken into consideration. But if possible, of course, yes, we will use the vehicle-mounted cameras to take whatever pictures we can. Okay, why don't we go to the next slide? One thing I didn't mention, well, we'll get to it here anyway. A question came up in the chat earlier about payloads on board, and National Geographic and Disney, they are flying a handful of little action cams. They're just basically GoPros that the crew will be using to document the operations and the activities on the mission, and that footage is going to be considered proprietary for Disney and Nat Geo, so that they can put their little documentary together something like a year after landing. So those cameras, I'm sure, will get lots of pretty pictures out the window and whatever the crew's doing, but NASA really won't have an ability to get to much of that footage until after Nat Geo's done with it. So this slide is really meant to convey what is different on this mission compared to the first flight. On the first flight, we had the SAW cams and a couple of the cab cams and a couple of other cameras mounted on the outside. So for Artemis 2, obviously the new stuff is whatever the crew brings with them. We've got the handhelds that I mentioned, the Nikon D5. Those 2 HH&P cameras, these are brand new. They're essentially GoPros. They'll be mounted to the forward part of the crew cabin bulkhead, and they are there for medical purposes to monitor the crew's response during dynamic flight, ascent, entry, and if there's any aborts. One of them will live stream during ascent. That's camera number 1. Both of them also record at high speed, and we'll be able to download that imagery post-flight. That little encoder there, that little black box, don't worry too much about that. That's just a way that we can get some of the live streaming video down. It can handle both HD and UHD formats. The caveat with, if anybody wants to live stream UHD, there's an attempt right now still underway to see if we can do that, but we have to have the optical comm system enabled. And that's a laser comm system that will only fly on Artemis 2. It's just a test on this one flight only. If it flies on future missions, it will not be on Orion. It might be on Gateway or some other vehicle, but we'll have to see. So the ZQ bottom line is that allows us to get the live streaming video down to the ground. Because we do have a crew on board, the crew is able to view the live output from each of the cameras on their display units. That's that little display on the center on the right side. There will be a new camera called the docking cam, or the DCAM, that's mounted center line in the forward hatch window, and it will be used for a rendezvous and prox ops demo right after Orion comes off the upper stage, still in Earth orbit. The spacecraft is going to immediately do a pitch around maneuver, and we're going to do some approach and piloting tests to the upper stage. They're not going to actually dock, but they're going to come close to the upper stage, and the crew is going to get used to piloting the vehicle, and the DCAM is going to be the prime sensor used for that operation. We will get some live streaming video down off of that for the first part of that test, and I think it's also a black and white camera, but it's mainly used for navigation purposes. That next pre-launch crew ingress, obviously that's nothing to do with lunar science. That's just a camera that we're going to be using on the pad to show the crew getting into the vehicle. The tablet there, I think it's actually called the portable computing device instead of personal. They changed the name on it, but that's the Microsoft Surface Pro, and that has all the Surface or all the Office apps and the crew's timeline and various other support applications. It also has a little webcam built into it, and we will be using that to do the daily crew medical conferences, family conferences, things like that. And I already mentioned the Nat Geo payload. So that's the new stuff that we're flying on Artemis 2. Why don't we go to the next slide, please? Okay, some of the big challenges. This is unfortunately where reality hits the physics of what the spacecraft is actually capable of. One of our biggest challenges, of course, is comm. Everything coming off of Orion has to go through the S-band system. We do not have a high gain antenna. We used to back in the Constellation days, but right now it's all phased array antennas at S-band frequencies, and everything has to come down through the deep space network. So our bandwidth is very, very limited. If we get the optical comm system up and working, we are hoping to be able to achieve something upwards of 20 to 30 megabits per second, but unfortunately, it's still just a test, which means we have to make the mission architecture close on the RF or the S-band system only. So as of right now, if we get the optical comm working, that'd be great because we can burst download a lot of big files, but we have to make sure everything works on RF only. So bandwidth and downlink capability is extremely limited. Onboard storage is also very, very limited. The camera controllers, those are the boxes that control the vehicle camera system. Those only have a couple hundred gigs each, so they are very limited on what we can use the vehicle camera's recording. The Nikon will have some compact flash cards flown. At the moment, we're planning to fly about 10 of them. Each one of them is 256 gigs, so that should be adequate storage space for a 10-day flight. But obviously, we have to take good care and monitor how those things are being used up. And if anybody wants to use the Nikon D5, it does indeed shoot both HD and UHD formats. But the UHD video, which is obviously the highest quality, does accumulate something on the order of a gig per minute. So if anybody wants to shoot 4K UHD out the window, chances are you'll have to wait for post-flight to get that video down because it's going to be too big for us to downlink during the flight. One of the biggest concerns, obviously, if we want to use the Nikon camera with the long lens for shooting the moon, is window quality. And as of right now, the Orion windows, by requirement, are supposed to be certified to what we call Category B, which means they're suitable for large lens photography with focal length something on the order of 400 millimeters or larger. Unfortunately, we did not pass all the specification tests that we liked on Artemis 1, so that the cameras were only officially certified to Category D, which means basically suitable for piloting ops out the window, eyeballs, and point-and-shoot type cameras with small lenses. They may, in fact, be Category B quality, but we do not have any photography tests right now that is a flight-like camera shooting through a flight-like triple window stack as to be flown on the vehicle. So that photography right now does not exist. So we have not yet fully characterized actual optical window performance with a flight-like Nikon camera. We are trying to do that. And if we can't do it on the ground pre-launch, we'll do it in flight, hopefully on flight day 1 or 2, getting the crew to take some pictures of the Earth. And that will help us inform, and this is the important part, that will help us inform how we tell the crew to configure the camera for the lunar flyby. It is possible. I'm optimistic that we can still use the 400 millimeter setting on the lens, but it is possible that we will encounter enough wavefront distortions from these windows that we may have to limit the focal length during flyby to something like maybe 100 millimeters. I know that's not ideal, but we're doing our best to characterize that as soon as we can. Next slide, please. Okay, this is just a quick overview of what's going on during the mission. Flight day 1 is going to be a very, very busy day. The crew's going to be very tired. They don't even get a full sleep period. It's kind of broken into 2 4-hour chunks. So obviously we've got to get them off the ground. They'll get into ascent. We're going to do some jettison ops. That's all system stuff. We're going to do the rendezvous and prox ops demo. Hopefully we can activate optical comm. The next couple of days, we're on our way to the moon. Nat Geo payload and some PAO events, lunar flyby on flight day 6. And then some more PAO and Nat Geo payloads on the way home. And then on flight day 10 is separation of the spacecraft and then entry ops. So that blue bar on the right side, that's in onboard data management issues. We have to move all the video from one camera controller over to the other before entry. But for Lunar Ops, again, it's all going to be on the handheld camera, and that imagery will be stored on the compact flash cards. So I know I ripped through that kind of quick, but next slide I think was just to get off the stage free card. Yeah, so if anybody has any questions, please let me know.